In this video, we will talk about graphs of functions. To begin, let a and b be sets and let f be a function whose domain is a and whose codomain is b. The graph of f of x is defined as the following set: the set of all ordered pairs x and f evaluated at x, where x is an element of our domain a. It is standard to look at ordered pairs like this and associate the left coordinate with our input and our right coordinate with our output. The traditional way or common way of doing this is to let the left coordinate be our x coordinate for a graph and the right coordinate be our y coordinate for a graph. To see an example, let f be the function from z3 to z3 given by f of x equals x plus 1 mod 3. First, we need to draw the grid. The horizontal line, or our x-axis, will display all values in the domain, and our vertical line, the y-axis, will denote all elements in our codomain. We will graph the function by evaluating each value on the x-axis and fill in the corresponding square. F evaluated at 0 equals 1 mod 3, so we will fill in the square 0, 1. F evaluated at 1 mod 3 equals 2, so we fill in the square 1, 2. And finally, f evaluated at 2 mod 3 is equal to 0 mod 3, so we will fill in the square 2, 0. And this is how you graph a finite valued function like the one here. In this next example, we will plot a graph from a given table. Consider the table of x, y values. We will consider the x values as input to a function and the y values as output to a function. So we can see that 1 will be mapped to 2, 2 will be mapped to 2, and so on. Start by drawing our axes and labeling all the values in our grid. We can see that the x value of 1 has a corresponding y value of 2, so I will fill in the square 1, 2. And in a similar fashion, I will fill out the remaining squares using the corresponding x and y values. In this next example, I will get information from a graph. Consider the graph whose x values go from 0 to 4, whose y values go from 0 to 1, and where the following squares are filled in. Using roster notation, we can list the set of ordered pairs of this graph. I have the square 0, 1 filled in, so I will write down the ordered pair 0, 1. Similarly, I have the square 1, 1 filled in, so I will do the ordered pair 1, 1, and so on. Using the x-axis, I can determine that the domain of this function is the set 0, 1, 2, 3, 4. Similarly, by using the y-axis, I can determine that the codomain of this function is the set 0, 1. Notice that I wrote an f next to the graph. That means that this is the graph of a function that I am calling f. So if I want to use function evaluation notation, I can use the coordinate 0, 1 to say that f evaluated at 0 is equal to 1. Likewise, the coordinate 1, 1 tells me that f evaluated at 1 is equal to 1, f evaluated at 2 is equal to 0, and so on. Then I will compute the image of this function. In other words, I'm going to compute the set f of x, where x runs through all values in my domain being z5. The image happens to be just the set 1, 0.